This is a short tutorial on density. Most of you are probably familiar with density, but it shows up quite a bit in Gen Chem, so it's a good idea to just kind of review what it is, what the formula is, and how to work with it. If you were to see this image, would you be able to explain in detail why some of the items sink to the bottom while others seem to be suspended and yet others float on the top? It all has to do with density. The definition of density is, in a real simple-minded terms, how much stuff is in a certain amount of space. And by stuff, from a chemist's point of view, we mean atoms and molecules. So it's how many atoms or molecules are packed together in a certain volume or unit of space. So the more tightly packed the atoms and molecules are, the higher the density, and the more loosely packed they are, the lower the density. So things that float in water, for example, ice cubes, have lower density than the density of water, which has been defined for convenience sake by scientists as exactly 1.0. The units we'll be working with in density are typically grams per milliliter or grams per cubic centimeter. So let me tell you right now, and I would jot this down if you don't already know it, that 1 cubic centimeter is the exact same amount as 1 milliliter. They're interchangeable. Now, I'm hoping that you're aware that the fact that solid H2O is less dense than liquid H2O is an anomaly. Almost all the time solids are more dense than liquids, but water is pretty weird in a number of ways. That's one of them. The formula for density, density equals mass divided by volume. And so it can be in a lot of different units, but the most common units for mass are grams, and probably the most common unit for volume in a density reading anyway is milliliters. But basically that tells you how much mass is crammed into a certain amount of space, which is defined as volume. All right, so let's talk about doing calculations with density. A lot of science instructors get upset for showing this, quote, magic triangle, but I've found for people who struggle with algebra that it's invaluable. And so if you don't struggle with algebra, I would not encourage you to use this. But the purpose of this is, if you remember the formula, density is mass over volume, and I ask you to solve for density, I don't think any of you would have a hard time. You plug in the value for mass, plug in the value for volume, divide them, and get your density. What if I asked you what a certain amount of mass is if given the volume and density? In that case, if you were solving for mass, you would have to rearrange this density formula. Those of you comfortable with algebra would be able to do it quite quickly. You'd be able to say, okay, well, in terms of mass, mass would equal density times volume. Those of you who perhaps struggle with algebra can get mixed up. It's almost like algebra dyslexia. So that's where this magic triangle comes in handy. So take a look at this triangle while I explain how to use it. Let's say you're solving for density. Whatever you're solving for, you cover up, make go away. So I'm just going to get rid of it. And then you look at what's remaining in the triangle, and that is your rearranged formula. So what's remaining is density and volume, and they're right next to each other, so it's density times volume. Let's try that again, and let's solve this time for volume. So let's say I asked you, what is the volume of a substance? And I'm going to this time give you density and mass. If you're comfortable with algebra, you would be able to rearrange this formula and say, well, okay, let's see, volume is mass divided by density. If you are not friends with algebra, you may choose to use the magic triangle, And remember, whatever you're solving for, in this case volume, you cover up, make go away. And now what's left? It tells you that when you're solving for volume, it is mass divided by density. Okay? So that's how you use that formula. In any case, however you do it, whether you use the triangle or you memorize the rearranged formulas or you're comfortable with algebra, you need to be able to easily solve all of those three manipulations of density. All right, so here's some practice. Here's a straightforward one. It says solve for density. So in this case, all you need to do is remember the formula. Density is mass over volume. Plug in your values and calculate. In this case, the mass was 35 grams, the volume 7 cubic centimeters. Remember that a cubic centimeter is identical to a milliliter. And when you 35 divided by 7 gives you 5, so the density of this material is 5 grams per cubic centimeter. Let's do another problem where you have to rearrange the formula. This problem is quite a bit trickier. If you feel that you are very comfortable with density and manipulating the equation and reading word problems, then I would recommend putting the video on pause and trying to work it out yourself. And if you can, you're in really good shape for density. If not, hang on and I'll walk you through it. So the first thing you want to do is keep yourself from panicking if it's a different type of problem than you've ever seen, and read it carefully. What I like to do is skip to what the problem's asking for. It's asking for volume. So I know that I need to rearrange the density formula so that I solve for volume. And whether you use the magic triangle or you can do algebra easily, you should come up with this. So I need the mass and the density. I'm given the density, okay? So I can go ahead and plug that in, 1.53 grams per cubic centimeter. My issue perhaps is that I'm given two masses. I'm given a mass of the empty container and I'm giving a mass of the container and the stuff that's put inside of it. So which of these masses do I want, if either one? Well, the density that I'm given is of carbon tetrachloride, and I have to match in order to get volume. I've got to take the mass and density of the same substance. So I need the mass of the carbon tetrachloride. So kind of drawing a picture here. Here's my container. It has a mass, empty, I'm being lazy, of 121.3 grams. When I fill it full of carbon tetrachloride, the combined mass of the empty container and the carbon tetrachloride is 283.2 grams. So if I want the mass of just the carbon tetrachloride, I've got to subtract out the mass of the empty container. Let's see if I do my mental math correctly. There. 161.9 grams is the mass of the carbon tetrachloride. And I'm going to go ahead and put that in, 61.9 grams. And of course, units cancel, and I'm going to end up with units of cubic centimeters, which is a perfectly acceptable unit for volume. And when I go ahead and carry out this calculation, I get when I plug that in, that the volume is 105.8 cubic centimeters. Okay, so basically it's telling us that the volume of carbon tetrachloride in the container is 105.8 cubic centimeters, which means that the container also has the same volume because it is completely filled.